Welcome to solverfy.
Okay, we have the following Fischer projection. We've got OHs on the left, two of them, OH on the right. We've got hydrogens in here as well. And for this type of problem, it's important to remember what it is that a Fischer projection represents. Remember, at every single crossbar, whatever's on the left and the right can be thought of as coming up and towards you, right? And whatever's going up or down is curving away from you, right? So the traditional way that we look at these five-member Fischer projections is we think of them something like this. We think of at the very top, in this case, we'd have a methyl group coming away from us. On the left, we'd have an OH coming up towards us. On the right, we'd have an H coming up towards us. Then we'd have a bond. Below that, on the left, we'd have an OH coming up towards us. On the right, we'd have an H coming up towards us. Another bond on the left. We think about now having an H on the left, right? Because there's an H on the left there. But having an OH on the right coming up towards us. And then finally, the methyl group would be curling away from us. So it's kind of like we have something bulging out at us like this, and we're looking at it down the spine, right? You can kind of think of it like if you had a banana. And you're looking at it such that it's curving out towards you. What you want to do, right? So if you're looking at a banana and you're looking at it curving out towards you, it just kind of looks like a thing, right? What we're going to do is rotate it onto its side such that we're viewing it from a profile instead of just looking at it. We're going to take it from looking at its back, but convert it back into looking more like a banana, right? We're going to go from this, rotate it to this, okay? And that's what we're going to do with this image right here. We're going to rotate it onto its side such that we now get a picture that is something like this, right? We've just kind of pushed it 90 degrees to the left such that this carbon, this methyl group, is now here, and this methyl group is now here. Well, what does that tell us about these hydrogens and these OHs? If we push this onto its side like that, the hydrogens that are on the right-hand side now are going to be coming towards us, and anything on the left-hand side would be going away from us. Okay, so this is really what Fischer projections are representing in 3D space. The idea now is that this OH will be in the back, this OH will be in the back, and this OH will be in the front. So we'll leave out the hydrogens, but show that we have an OH in the back here, an OH in the back here, and a hydrogen in the front. Okay, so now we've pushed we've effectively just pushed our Fischer projection onto its side. Now, the final thing is that the molecules we've been given to pick from aren't shaped like this. They're shaped like this. So we'll have to sort of unwrap this Fischer projection by rotating about the various bonds until it does look like that. And the way we'll do that is we'll take the whole thing and kind of rotate it on the page such that the first bond, such that this and this will look like this and this, right? So that's priority number one, is we're going to move to this, 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 and this. Okay, so our first, so that's an OH. Our OH is still coming towards us here, and these ones are still going away from us. so. And now what we need to do is take this bond and have it point up and to the right instead of down. Okay, the way we do that is we rotate about this bond by 180 degrees. Okay, so if we do that, so we now have that, well, now our tail piece, rather than pointing down to the left, will be pointing up. Okay, and the other consequence of that is that since we rotated everything by 180 degrees, if an OH was after the rotation, so after this carbon, pointing away from us, it will now be pointing towards us. Okay, and our final bit of thing that we have to do is rotate once again around this bond, right, such that this bond is now pointing down and to the right like the ones in the pictures. And once again, we do that by rotating by 180 degrees about this bond. Okay. And the consequence of that, again, is that any wedges after that rotation will become dashes, and any dashes after that rotation will become wedges. Okay, so this will remain a wedge to an OH. This will remain a wedge to an OH, but what used to be a wedge there will now become a dash. Okay, and this is the final form of our molecule. We'll notice that we basically got wedge, wedge, hash, and there are no molecules given to us that have wedge, wedge, hash. We've got 3 hashes. We've got wedge, hash, wedge, but we do have wedge, hash, hash. Okay, so is that equivalent in some way to wedge, wedge, hash? And the answer is yes. So if we think of this as being like a playing card, okay, and we think of maybe turning the playing card over, right? So this was, let's say, the back of the playing card, and then we flop it over such that we're now looking at the front of the playing card. What would have happened is that what was previously on the right and facing away from us would now be on the left and facing towards us. What was in the middle and facing towards us would now be in the middle and facing back. And what was on the left and facing towards us would now be on the right and facing away from us. Okay, and so we can see that this matches molecule 3. Okay, so that's conceptually how to think of Fischer projections, right? They're very similar to the idea of if we had a banana, okay, and maybe this banana's got arms. Let's say his right hands say R on them, and his left hands say L on them, right? A Fischer projection is we look at its back, and it says R, 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 all on the right, L, L, L on the left, and its little banana stop pieces are there.